This should be a relatively short lecture just looking at the protein requirement and some diseases that we know to be associated with proteins. How much should we eat? You remember the estimated average requirement, that term. For men and women 19 years old and older, the estimated average requirement is 0.6 grams per kilogram body weight per day. There are tables if you look back in your textbook, but also in week 5. I think I posted the tables again. You can look at the EAR for various age groups, but they're slightly higher for teenage men and women, but then about 0.6 once you're older than that. And the EAR, you might recall, is the average requirement that would meet the needs of about 50% of the population. The RDA, on the other hand, meets the needs of about 97 to 98% of the population. But you notice the requirement is not that much different, 0.8 grams per kilogram of body weight per day. And most Americans exceed the RDA, so over exceeding the estimated average requirement. And then another way to look at protein requirement per day would be the acceptable macronutrient distribution range, and that number is about 10 to 35% of calories. Again, for most people, if you're looking at the EAR and the RDA, roughly speaking, 10, maybe 15% of calories coming from protein would meet the EAR or the RDA. Going above that, into the 20%, 25, 35% range, really the only need to go there would be if you were really looking to build significant amount of muscle mass, or if you were a professional athlete, not even just a very active person, but a professional athlete. And even a lot of professional athletes, depending on the sport, don't exceed much above low 20% of their total daily caloric intake from protein. Also really interesting to just keep in mind that at intakes that are above, roughly speaking, 20 grams of protein per meal, just because of the slow digestive process of the proteins, we can absorb beyond 20 grams per meal, but we won't typically utilize more than 20 grams within a 2 to 4 hour time span. And when I say utilize, I mean absorb either into muscle tissue or use, contributing to the amino acid pool for tissue regeneration. So beyond 20 grams per meal, most amino acids will then go and be utilized. If you remember that diagram from the primary proteins lecture, may be converted into glucose, may be used as a source of energy, but could also be converted into triglyceride and be added to the adipose tissues or fat storage. And I want to revisit this concept of ammonia. So when we have amino acid breakdown, so when we aren't using the amino acids, the body does have to get rid of the nitrogen compound, the amino group in the amino acid. So again, in the liver, we will convert the amine group into ammonia and then into urea. And the urea will travel from the blood to the kidneys, and the kidney will then excrete the urea. So just starting to understand too that remembering that ammonia is a toxic product. So as soon as we start to consume on a regular basis more protein than the body really needs to utilize, we will start to see this process taking place, which can over time cause pretty serious damage to the liver and to the kidney. So that processing out of the ammonia. And I just want to touch on foods that are rich in protein outside of meat. I think most of us are pretty well understanding that meat is a rich source of protein. And interesting, though, too, to look at the amount of protein in various cuts of meat, and comparing that to the total daily requirement for protein, because you might find that the average serving in the United States of meat at one meal is actually providing enough protein for the entire day, or almost the entire day. So I do think it's worth pointing out that a lot of our plant foods are also actually pretty rich sources of protein. And if we were to eat an entirely plant-based diet, most people, if it were plant-based and not junk food-based, would be consuming adequate amount of protein. So across the world too, we'll see that vegetarianism is quite common, and for various reasons. In some places for religious reasons, especially in the United States lately for ethical reasons, and increasingly for health reasons, as we're starting to see a lot of information finally making its way to the popular media about the pretty serious adverse health effects of what we call the standard American diet, which is rich in animal proteins, animal milks, and basically processed grain foods with added oils, added fat, and added sugar. So not necessarily just switching to a vegetarian diet, but switching to a cleaner diet, eating less processed foods, which does typically mean eating less meat in general. And then for food safety reasons too, so just knowing that a lot of bacterial viral diseases can be transmitted through animal flesh, and that the animal agriculture industry is not always the cleanest. So depending on the food that we're consuming from large animal agriculture operations, especially in my opinion, there's plenty of room to worry or be concerned that it's not literally the cleanest, most sanitary food. So then I just want to point out a couple of benefits too of eating a more plant-based diet, or vegetarian, or even vegan diet. So total reduction in blood pressure, reduction in risk of cardiovascular diseases and cardiovascular events, reduction in diseases relating to digestion, so Crohn's disease, colitis, irritable bowel disease, constipation, and a pretty significant reduced risk of and incidence of various cancers, in particular, again, liver cancer, colon cancer, kidney cancer, stomach cancer. Those are some of the big ones that we see reduced on a vegetarian or fully plant-based diet. So why, some of the things that again are coming to light, the research has always been there, but for some reason it just hasn't made its way to the popular media or to people in general. But a couple of the main reasons why excess protein can be kind of damaging to the human body, again, particularly when it's coming from the standard American diet, which again is not only in excess in protein, but it's also in excess in added oils, added sugars, and processed foods. So sort of fake made up foods. So we know then that these diets are really high in saturated fats and cholesterol, and we know that these molecules in excess in the body can actually inhibit the body's ability to respond to insulin. And you remember from the carbohydrates lecture that insulin's job is to encourage body cells, particularly muscle and liver, to take glucose up out of the blood. So with insulin resistance, eventually we see type 2 diabetes. Also, a diet high in saturated fats and cholesterol and added sugar typically coincides with overweight and obesity, and that seems to be the starting place for insulin resistance and things like plaque building up in the blood vessel walls. Also, once we have plaque buildup in the vessel walls, that alone might not be super problematic, but the problem is when that plaque does rupture and we have a blood clot then in the middle of the artery. And so we know that the more that we take in foods that are high in saturated fats processed foods, added oils, added sugars, we see the likelihood for that plaque to rupture. So obesity, insulin resistance, type 2 diabetes, cardiovascular events, and then also the promotion and progression stages of cancer development. We have seen in the scientific research that these stages of cancer are quite impacted by excess protein in the diet. And then the other piece is just that the excess protein itself, but especially in conjunction with that standard American diet, that high processed foods, high added oils, high added sugars, will start to acidify the blood. And again, you might recall we've talked about how it's important for the body to keep its blood at a pretty neutral pH. So once it starts to become too acidic or too basic, the body will respond to try to restore it to that homeostatic, more neutral level. And so one of the things that the body may do when it becomes too acidic is to pull calcium out of the bones to try to bring a more basic environment to the blood and balance out the acidity. And then just a couple of slides on some diseases associated with proteins. So on this slide, we'll start with marasmus and kwashiorkor. These are two diseases that we don't see really in the United States much at all anymore, but these are diseases we do still see a bit worldwide. Mostly they're diseases associated with like under consumption of total calories, period. And so underconsumption of total calories would also be an underconsumption of protein. So marasmus is kind of, again, just not enough calories. It's sort of a slow starvation. The body starts to sort of eat itself. And then kwashiorkor is a disease that we see. We know it can actually be sort of reversed. We see it typically if infants are weaned too early from the breast milk and they can't take whole food yet. So if these infants start showing signs of kwashiorkor and then they're given breast milk again, they seem to recover pretty well. And then two others are sickle cell anemia and cystic fibrosis. Sickle cell anemia, we're going to look at some anemias too when we get into our vitamins and mineral lectures, but this is where we see red blood cells that are irregular shapes and therefore not functioning properly. Sickle cell anemia we know to be a genetic disorder, and cystic fibrosis, and also again I'll back up to red blood cells being proteins, and then cystic fibrosis, we have poor transportation of chloride within the body. This again being the responsibility of protein, and this affecting the linings of the lungs and the pancreas the most. And once we see that, we see sort of mucousy development and leading to breathing difficulty and stunted growth. Lastly, I want to talk about some diseases associated with excess protein consumption. And we did talk about this briefly on the previous slide. And there is actually a scientific article posted to the content for this week where you can look through a really nice review article that goes over several different studies that have looked at these types of diseases being associated with excess protein intake. So again, just diseases with bone and calcium homeostasis. Again, so if the body's pulling the calcium out of the bone to neutralize the acidity in the blood caused by the processed food intake. Again, kidney and liver disorders associated with that ammonia processing, so getting rid of that amino group. And again, the only reason we need to get rid of the amino group is if we have more protein than we actually need. And once we have more protein than we actually need, we will convert that carbon backbone to either make some glucose or make some triglycerides, and we don't utilize that amine group. So the amine group then has to be processed out through urea and then ammonia. And then the cancer risk and the coronary artery disease. So again, sort of new on that previous slide, those are diseases that we've been dealing with for a good couple of centuries, several centuries. So they've been around, we've known about them. And these are sort of diseases of the modern day, really. So we're sort of just starting to tune our attention to how these diseases are related to our eating habits, but kind of in the opposite direction of the previous slide, where the previous slide is typically not enough consumption. This slide is looking at diseases associated with too much consumption.